So I think we're all like pretty familiar with failure if you were working in IT, right? So I think we encounter like issues like on a daily basis, and maybe you're as old as me and you've actually seen this message like in the wild. So task failed successfully. It was an information message on Windows XP. I've definitely seen this, but this is of course like a very weird thing to show to your end users, right? An information message about the task failing successfully, and the only thing you can do is press OK, and then that's it. But this message, task failed successfully, is actually what this is about, because we know things are failing, like it's inevitable. But let's actually make sure that it fails without having a very big impact on the end user. And so we actually want things to fail successfully because things will fail anyway. So let's make sure that we're not impacted that much if things are failing. I will skip my bio. I think most of you know that I'm a developer at Dapr. I'm one of the Dapr community managers. So I did a bit of research of failing IT projects, and I came across this blog post on the IEEE Spectrum blog. If you look at it now, some of the images and charts disappeared because they were hosted on Glitch, and Glitch is now decommissioned. So unfortunately, most of the content is not there anymore. But it was like a very nice interactive blog post that showed what are the lessons learned from a decade of IT failures. So the first thing was like a graph that you see here, and along the axis you have the years, and then you have like several geographic regions, and all of these circles are like the cost of those failures. And as you can see, the biggest circle here is worth like 10 billion in US dollar in cost, and some of the circles here are even much bigger. So the total chart is like in many billions of IT cost. And I'm not saying that what I will share with you now can prevent all of this, because there are like many reasons things can fail, and especially IT projects can fail. But I think we can definitely do something to limit the impact of the end users if IT is failing in general. So what I really liked was a quote from this blog post, and it mentions a rogue algorithm led the United Capital Group to lose 444 million in errant trades in about 45 minutes in 2012. So, well, it's a mind-boggling number to lose so much capital in just 45 minutes by an algorithm that has a bug. Okay, so why are things, why are failures happening? Well, one of the things that are contributing to this is that, well, building distributions is very hard, right? So we've already heard that from a couple of speakers. And we have like several applications that need to communicate with each other, either synchronously or asynchronously over like message brokers. There are different state stores involved, and sometimes those also need to be synced. So yeah, developing this can be really tricky. And this is actually quite well known, right? So there's something that's named the fallacies of distributed computing. So it's a false set of assumptions programmers new to distributed applications often make. And this is a list of assumptions that's already from 1994, right? So that's already quite old. I'm not going to go through this list because it's not really a theoretical session, but this list of fallacies is quite well known. And if you want to know more about it, I can definitely recommend you some of the links here. The bottom one is especially very nice. It's like a YouTube video with a playlist where Udi de Haan from Particular Software explains these fallacies. But it's good to realize that not all failures are the same, right? So you have like transient failures, and those failures are like temporary and usually resolve themselves without any human intervention. But that actually means that someone has been there before you and actually thought of a way to resolve it, right? So there's either a fix in hardware or in firmware or in software. So that can actually be resolved automatically. And then there are permanent failures, and those are the opposite, and they do require human intervention to be resolved. And so, for instance, someone introduces like a bug in an application. Well, this bug will not be resolved automatically. A developer needs to look at it, needs to change the code, needs to deploy it again. So that requires human intervention. Well, most of you are familiar with Dapr, right? So Dapr is built actually to help create and run distributed applications, right? So that takes away some of the heavy lifting that you would normally need to do. So that's great. And again, it offers like a very big tool set of different APIs and cross-cutting concerns. But the only API that I will cover now is the workflow API here. By the way, if you're very new to Dapr, there's something called Dapr University. There'll be a link shared later where you can get this. So this provides like a nice sandbox environment to learn about Dapr. So the problem that we want to solve is we know that systems fail, so that's a given, and we need to make sure that we recover from failure, and ideally automatically, and to limit the impact of the failure, right? So that's what we want to do. So for this, there's a concept called turbo executions, and that concept is implemented by workflow systems. So turbo execution guarantees that code is run to completion, even if the process that runs the code terminates. So turbo execution ensures that another process is started and that the code is resumed until it completes successfully. And this is realized by persisting the state of the execution to a state store. So yeah, if you're not familiar with these systems, it sounds very strange. That's the process that it terminates, but another process will just pick up and continue, and that's possible because the state of the execution is persisted. So if it sounds familiar, then you're maybe used to using workflow systems, right? So these have been around for decades, and they're used to automate all kinds of business processes, some even like very long-running or never-ending business processes. And they implement this turbo execution concept. So, and these workflow systems, they consist of like several parts. So you always have like an authoring environment to create the workflow. You have a workflow engine that actually runs and executes and schedules the workflow. And there's like a state store to persist the workflow state. So you always have these three components. Now, this is an animation to show what's going on when a workflow is being executed and how the interaction goes between the workflow and the state store. And so as soon as you schedule a workflow, that input of the workflow is stored here. When the first activity is then scheduled and executed, also this input is stored. When it's done, the output of that activity is stored. Then the workflow will not continue executing the second activity, but the workflow will replay from start, and it will get the results from the first one from the state store. Then it will execute the second one. Again, it will not go with the third one, but again, it will replay. It will get the results from activity 1 and 2. Then activity 3 will actually be executed and done. All of the inputs and outputs will be stored. And then there will be like a final replay where all of the information from the activities will be rehydrated from the state store. And then finally the workflow is done, and then the output of the workflow will be persisted to the state store. So as you can see, there is like a lot of I/O going on between the workflow engine and the state store. But yeah, because of this I/O, because the state is persisted, if the workflow fails at a certain point, it doesn't matter because all of the state of this workflow is stored. So Dapr workflow, is also one of the systems that implements this turbo execution concept, and you can actually author your workflows in code. So you can use like C# or Java or Python or JavaScript and Go, and you can apply all kinds of programming patterns. So here's just like a high-level example of what you can do with a workflow. So for instance, you can start a workflow by receiving a message, then you use an activity to retrieve a Dapr secret and use that secret in a Dapr invocation call. Then you wait for an external event to receive. Then you execute 2 activities at the same time. So that's called like a fan out. So you store something using the Dapr State Store API, and you invoke another API. And finally, we publish a message using the Dapr pops up, again in another activity. And so basically what happens in a workflow is nothing more than calling activities. And in the activities, you have the actual communication with other systems. And there's some business logic inside this workflow that decides the sequence and the flow, the logic flow. So when it comes to like authoring, so Dapr uses a workflow as code approach. And so we use like code that developers really like. I also really like it because, well, it's part of source control, right? It can be unit tested. So it's really nice, I think, to use code as your workflow authoring environment. The downside typically is that there's no visual representation of the workflow. But as you have seen in Mauricio's session, there's actually a tool for that called Catalyst, which actually offers like a visualizer of the Dapr workflow. So that's great. There are also like many other workflows called solutions. So this last link might be interesting if you're interested in general looking into these workflows. Code solutions is called awesome job executions. So that's like a GitHub awesome list that contains like dozens and dozens of links to other projects that offer like similar solutions. So definitely have a look into that. All right. We will skip this and let's talk a bit about the different workflow patterns, because if you're using Dapr workflow or any workflow system out there, you actually can use different workflow patterns, which you might not typically use if you're not programming with workflows. So the most basic pattern you can do is called task chaining. And that's just really like a sequence of activities that are called in a specific order. And you do that because maybe the output of an activity is used as an input for the next activity. So here we do first A and then B and then C, because maybe B requires something from A and maybe C requires something from B. So that's why this is important. The next pattern is called fan out, fan in. So this is useful when there's like no relation between all of the activities. So these can all be scheduled and executed in parallel as much as possible. So these can either be like different activities. So here we have like 3 different activities, A, B, and C. But these can also be the same activities, but then the input for all these activities can be different. Then there's the monitor pattern. So you can use that if you want to have some kind of a reoccurrence of an execution of an activity. So let's say you want like a nightly cleanup job of some cloud resources that you want to dispose of. So you can start your workflow in this activity you call to maybe like a cloud API to clean up some resources. And then you can instruct the workflow to create a timer. So then it will wait. And after the timer is exceeded, you instruct the workflow to continue as a new instance. So this is something else than the replay pattern I showed you before. This means you continue as a fresh instance. You forget all of your historical executions and state. You start really as something new. Right. Another pattern is the external system interaction. So that's great if you want to pause your workflow and wait for an external event. And that can be like an external event that a user presses a button to say okay or not okay, or maybe it's like a completely automated system. Maybe you are waiting for a pop-up message to come in, for instance. This is very, very useful in typical like approval workflows. So maybe I want to buy like a super expensive laptop, but that's exceeding like a certain price, and my manager needs to approve that. Well, that's a typical thing you can implement with the external system interaction pattern. In this activity, we send a message to our manager to ask for approval. Manager presses a button, which results in an event coming back into this workflow. And then we can inspect this payload. And if the event says, yes, it's approved, we can choose one branch of the workflow. If it's not approved, we can choose another activity of this workflow. Another pattern is a child workflow, so parent and child workflows. So you can actually create a workflow that contains of other workflows, and those are named like child workflows. It's generally advised to cut up a big workflow into smaller chunks because it's easier to reuse these chunks. It's also better like readable as well. So if things really belong together, you can group certain activities together in a child workflow. And these child workflows, you can either then chain them together, like I'm showing here, but you can also apply the same patterns for these child workflows. As you can also do like a fan out, fan in across child workflows as well. All right, so let's talk a bit about the Dapr workflow engine. So the Dapr workflow engine is built into the Dapr sidecar. And if you're familiar with Dapr, you know that every application that you have, it will have like a Dapr sidecar running next to it. And as soon as your application is starting up, this Dapr sidecar is also starting up. And there's like a bidirectional gRPC stream set up between them. And then Dapr will read if there are any workflows in your application. And if there are workflows, then it will check in the state store if there are like any unfinished workflows in there. And if there are any unfinished ones, this workflow engine will actually schedule these workflows to actually rerun them and try them until they have been actually successfully completed. If you zoom in a bit in this workflow engine, Dapr workflow is actually built on top of the Dapr actor system. And the Dapr actor system has existed in Dapr since version 1. But workflows are using actors actually for storing the state and for scheduling the work. So there's an orchestrator actor type for each type of orchestrator, or each type of workflow, and there's also an activity actor for each type of activity. So that's actually the implementation of how workflow is using these actors. You don't really have to know this, and you're definitely not interacting with these actors yourself. But if you start the workflow and you inspect the Dapr logs a bit, you'll see a lot of mentions about actors. So I think it's good to know that workflows is built on top of Dapr actors. Okay, so I'm going to run a demo that consists of 2 applications. There's one workflow application that's interacting with a state store, an inventory, and it's also interacting via servicification with a shipping application. So if we look at the actual workflow itself, I called like a validate order workflow. So what happens is an order comes in, and the first activity is we are actually going to check the order against our inventory to see if we have enough inventory. If there is sufficient inventory, then we continue, and then the next activity is, okay, get me all of the shipping providers that can actually fulfill this order. So this will get back a list of shipping providers, and then we'll go to loop over these shipping providers, and we will get the shipping costs for each of the providers. Then we will check which one is the cheapest one, and for the cheapest shipping provider, we will register this shipment. If that is a success, well, then it's all good. Then we enter workflow. If this is not a success, so this is built in the try catch, then we are going to undo this update inventory. So that's something that's quite typical for workflows. You can define a certain compensation action, and since in this case I already updated the inventory as the first step, if something goes wrong and I cannot actually fulfill this order, I'm going to undo this inventory update in a separate activity call. Now, some workflow engines have like a dedicated built-in syntax for this, but in case of Dapr workflow, you have to create your own activity with your own business logic to compensate this action. All right, so I'm showing some examples in .NET. So .NET 9 application, it's a web application, and the only dependency I have is a Dapr workflow SDK 1.16. This is the actual workflow code. So we are seeing here that we are have a validate order workflow class, and that's inheriting from the workflow base class, and that's part of the Dapr workflow. So there's an input type and output type specified here, and as soon as you do this inheritance, then you need to override the run async method. And the run async method takes a workflow context, so that's the built-in type that you get from Dapr workflow. This contains all kinds of methods and properties that you use in your workflow, and you specify your own input object. This can either be like a simple type or like a complex type. I'm using a records type here. So you use this context to make calls to different activities. And so that's what's happening here. We are awaiting using the context to call out to an activity. Then you specify what kind of output type you expect back, an inventory result. You specify the name of the activity. In this case, it's update inventory that we're calling. And we're providing it an order item. So that's the input type for the update inventory. And since we're awaiting this call, what will happen is the workflow itself will stop with further execution. This update inventory activity will be scheduled and executed. And once that is ready, the control flow will come back into this workflow, and then it will continue with the next step. So we can then inspect the output of this inventory result. So if it's sufficient, then we'll actually get all of the shipping providers. We give it a payload. In this case, it's a specific request. But notice that we are now also providing a workflow task options, and that contains like a workflow retry policy. So that's something that you can do. So you can provide additional resiliency parameters when you are calling activities. So in this case, we have a workflow retry policy, and a number of attempts is 3. So in case this activity fails, we are going to retry it 3 times. And the first retry interval is after 2 seconds. So this is like a constant retry policy, but you can also do like exponential back off, etc. So what we have then we have the, this is like an array of shipping providers here, what we get back. So this shipping providers is like an array of all of the shipping providers. So we're going to for each over that. So we're doing an iteration. And here we are calling another activity, the get shipping cost. But this is actually this pattern actually describes the fan out, fan in part, because what's happening here is we first have like an empty list of shipping cost result task, and we are adding tasks to it. And notice that we are not using the await parameter here. So we are not awaiting this call. So these calls are not scheduled here at this moment yet, the get shipping cost. It's simply we're adding the task to this task list. And here at this line, this is the place where we're actually executing or actually scheduling all of these calls, and our application will actually execute all of the activity calls to get the shipping costs for all of these providers, and the workflow will wait until all of these activities has been completed. So once all of these tasks have been done, we have the cost, and then I'm using a min by to actually find out which one is the cheapest. And this is the part where I use like a try catch. I try to call this register shipment activity. In case that fails, we catch the workflow task failed exception. So that's something built into Dapr workflow. Again, you can always inspect like what is the actual inner exception then. And in this case, if this register shipment fails, we want to execute our compensation action. In this case, we want to undo the update inventory. So this is an undo action of the very first one, this update inventory. All right, just to show you an example of an activity. So this is an example of an activity class in .NET, inherits from workflow activity. It's pretty much the same thing. Again, need to override the run async method. And here we're using the Dapr client to actually interact with a Dapr state store here. This is another activity, and in this case, we're using an HTTP client to make a service verification call to the other service, to the shipping service. So that's what's happening here. We're using the HTTP client to do a post to the calculate cost endpoint of this other service. So this is the calculate cost endpoint of the other service. So what I intentionally do here is I do a thread sleep because this is important for my demo, because when I run the demo, I want to stop everything and sort of enforce that something goes wrong, and then everything will restart. So this uses just some randomization to giving back some cost. Okay, the final class that we need to look at is the program CS. So this is the startup class. So what's important for .NET is that you need to register your workflows and your activities in your program CS file. So this is a bit different compared to the other languages. So for instance, for Java, you don't need to do this. Also for Python, you don't need to do this. But for .NET, you need to register these activities and workflows. Otherwise, when this connection with the Dapr sidecar is set up, Dapr would not have any clue that you have like workflow code or activity code in your application. All right, so what we'll do very shortly is call this validate order endpoint. And this is using the Dapr workflow client. And you use the Dapr workflow client to do all kinds of workflow management operations. So in this case, we are actually scheduling or actually starting a new workflow. We specify the name of the workflow. We specify an instance ID. So all workflows have a unique instance ID that you need to also query the workflow later. If you don't provide one, Dapr will create like a GUID, but if you provide one yourself, you can. That's also fine. And you specify the input of this workflow. All right, and there's some other endpoints to actually make sure I have enough inventory to do the demo. Now, Dapr workflow, works because there's a state store that actually contains the state of the execution. And as I mentioned, Dapr workflow is built on top of Dapr actors. So in order for this to work, you actually need to make sure that whatever state store you use, Dapr compatible state store, you need to make sure that this actor state store value field is set to true. So that's important. Okay, almost about to run the demo now. So I'm using Dapr multi-app run to run both of my applications. So I'm running the workflow app, which is a .NET application. I'm also running the shipping app, which is a .NET application. And these are my app IDs. I'm also pointing to a resources path because that contains like my component file that defines my state store. All right, so what I'm going to do now is I will first build the applications and then I will run everything using Dapr multi-app run. Let's wait until it's built first. Okay, it's being built. So I'm going to run the applications now. And by the way, I've scripted everything, so that's why I'm not typing, but everything is running here locally in this dev container. So applications are starting up now. So we have a workflow app running and a shipping app running. I will make first some calls that I have enough stock in my inventory. Okay, so that should be good. Let me see. Yeah, so I now have a quantity of 5 of my rubber duck 1000. So that's good. So now I will make a post request to the validate order endpoint, but very quickly I will then stop the entire process to simulate that something bad happened, right? So this will kill my workflow app, it will kill my shipping app, it will also kill the Dapr process as well, just to indicate that something severe happens. Then I will restart the applications again using multi-app run. And then we should actually see the power of Dapr workflow, that it will just continue where it left off. Okay, so I'm doing this, start the workflow now. I'm going to make this request. It will start it. Now I'm stopping it. I will scroll a bit up here in the application logs and Dapr logs. Because the last thing that we saw in the application logs is that our requests were received by the shipping app in shipping service A, shipping service C, and B to calculate the shipping cost. So that's what happened in the last time. But the shipping apps were not able to send anything back yet because then I killed all the applications, right, to indicate that something severe is happening. So what I'm going to do now is I'm going to restart all of the applications, but I don't need to make this call again, right? Because there was a workflow running that is now sort of the state's now in the state store. So let's see what happens if we restart the applications. So again, I'm using Dapr run-f to point to this YAML file that contains the definition of my application. Everything will be up and running. So now we are at the same point again that we're contacting the shipping app, but now it will actually progress. And we actually see that some logs that have workflow completed with status, orchestration status completed, right? So we can already see from the logs that Dapr workflow was actually successfully continued, even though the process was still completely killed before. So we can actually check the workflow status as well by calling another endpoint. So let's check the status and we get back 200 OK, and the status is indeed runtime status completed. So that's pretty cool. Okay, let me stop this. All right. So the other demo I can do is to indicate how you can actually trigger this compensation action, right? So if there's like an exception, you catch the exception and you want to execute another activity based on that. And so what happens now, if we call this register shipment endpoint, it will always return like an OK with the shipment result. So let's actually purposefully change that just to show what's going on. So if we do like a 500, so each time we call this, it will just give like a server error. Let's quickly rebuild the shipping app because that's now changed. Now let's run it. So now I won't stop anything because as soon as the workflow is actually contacting the register shipment endpoint, something will go wrong. But then the compensation action will be executed. So in the end, the workflow state will be fine. It will still be completed. I do need to, again, make sure that I have enough inventory, and I do need to start the workflow as well. Oh. Okay, so I'm starting the workflow, but now I'm just letting it go. And at a certain moment, there will be an issue. Okay, so we still see that the workflow is completed with the status, orchestration status completed, right? So, and that's also the intention. We want to fail successfully. So this happened, but we see that we did fail to register the shipment. So there should be. So here we see that we have reverted the inventory update for this product. So this is proof in the application logs that we actually executed this compensation action. All right. I think, I will mention like a couple of things more, and then we will go to our next speaker, because I think it's important to mention a bit about workflow management, but also some tips and tricks about workflows. So there are some workflow management operations that you can do. So I've already showed you that you can start a workflow, that you can get a workflow instance state is very important, but you can also like pause a workflow. So maybe you already know that something will go wrong when a workflow is progressing. You can actually pause the workflow. Maybe you can fix something there, and then you can actually resume the workflow instance. You can also terminate a workflow instance. So maybe a workflow is in a bad state and it won't recover automatically because something is broken. You can actually terminate the workflow instance as well. And finally, you can also purge the state of a workflow instance, because by default, Dapr will not remove any state in your state store. So you're responsible yourself to actually remove that state. You can either do it on a per instance basis using the Dapr workflow management API, or you need to have some kind of a cleanup job running in your database. So these are all of the HTTP endpoints that you need, but you noted for everything you need like a workflow instance ID, except for the first one when you started, then it's optional. Okay, just some tips when you are dealing with workflows. It's very important that the workflows are deterministic, meaning if you run the workflow with the same input, it should always result in the same output. So it's really very important that whatever you do inside your workflow, you should avoid all kinds of random generation of data there. So for instance, we see that this non-deterministic workflow is using an order ID based on GUID, no GUID inside the workflow class, and also an order date based on date time now. But as I've shown you, a workflow will do a replay a couple of times during its lifetime. So what happens during a replay, this order ID will change, because for each replay, this GUID, no GUID will be called, and this datetime UTC now will be called. And if you use these objects as an input for activities, you will have like a mismatch between what's in state store and what's now here during runtime. So you want to avoid this. So luckily there are some operations on the context that you can use. So for instance, there is a new GUID method on the context. So this gives you a replay save method of a GUID. And there's also a property called current UTC datetime that gives you like a replay save datetime. And so this is fine to use this in your workflow code. If you have any other operations that are non-deterministic, you should always wrap them inside an activity, because the inputs and outputs of an activity are always stored to the state store. So it doesn't really matter what happens inside the activity. Another important thing is your activity. So activity should be idempotent. And that means if you run the activity multiple times, it should not have any side effects. So that's because Dapr workflow actually guarantees at least once execution if something goes wrong in the activity. So if your activity throws some kind of error, it will be rerun again, and then you can apply also these resiliency policies to these activities to replay them again, or retry them again. But you have to make sure that whatever code is running in your activities, it should be able to handle these situations. So, for instance, if you are want to do an insert in a database, can you run that insert statement twice, right? Or do you do a read first and then a write, or do you do an upsert, things like that? Another very important and tricky thing is workflow versioning. So versioning workflows is really, really quite hard, and it's very easy to introduce a breaking change in workflows, so which could then lead to a mismatch between like data that persists in the state store and at runtime. And that's because when a workflow instance is not completed, so it's in flight, and you deploy a new version of it, and then all of the old state will be like rehydrated and will be reintroduced in the runtime. But yeah, there's a very high chance that there will be like mismatches if you change the workflow a lot. So there are like different alternatives and different solutions for this now. A very basic one that you can use like a version suffix in the workflow name. So you can start with workflow v1 and then workflow v2. So never make a change to the workflow. Always make a copy of it and update the name. The downside of it is that the client that manages and calls the workflow also needs to be aware that there's this new name. Maybe you're sort of in a position that you can wait until there are like no in-flight instances anymore and then deploy your new version. The tricky thing is you have to really monitor all the instances and wait until they are completed. And that's very hard to do and to know at the moment. Another solution which is very safe, is to do like blue-green deployments, right? So you deploy in a separate resource. The old application keeps running and can still complete all of the in-flight, but new requests are handled by the new instance. This, of course, requires more setup, also cost more, and you still need to monitor to know if the old app is completely, if it's finished, if it's really no more in-flight things anymore. I know that the Dapr maintainers and contributors are now working on built-in versioning solution inside for Dapr workflow. So that will be like a big benefit to have like a really solid solution for Dapr. So hopefully we'll see maybe a preview of that already in 1.17. I really hope that will be there. Okay, I will skip this. The final tip is really to keep payload small, right? So I've shown in the animation, there's a lot of I/O happening between the workflow engine and the state store. Especially if you have like many activities and you start passing around like very large objects between the activities, all of these needs to be stored. So there's a lot of serialization and deserialization going on. Which is not very effective, and it will take some time. So it's best to only pass around IDs, and then in the activity you actually use that ID to retrieve a document, make an update, and then to save another document. So be mindful with small payloads. All right. I think that concludes all of my workflow tips for now. So let me know if you have any questions about this. Otherwise, feel free to check on Discord, because I spent quite a lot of time there as well. So feel free to reach out there.